Okay, thank you. Thank you for joining me for this session. Actually, this is my first time uh, attending the Spark Summit and doing the presentation here. And I'm very excited to be here with you in Dublin, which is a very lovely city. So today my topic is Spark structured streaming helps smart manufacturing. And first of all, I'm going to introduce myself. I'm currently working at Intel Big Data Engineering team based in Shanghai, China, which is very far from here. Right? I actually joined Intel from 2006 and focused on performance optimization for CPU, GPU system and applications for the last 10 years. Our team's mission is delivering the best Spark performance on Intel platforms. Intel is a hardware company. It produces CPUs, platforms, and a lot of other things. And our team is a software team. Our team's mission is to help a Spark system and Spark applications to run best on Intel platforms. And another mission of our team is to help our Intel's customers from different areas, different fields. Manufacturing is one of the fields. We help them to build a reference big data platform and combining Intel's hardware and big data software such like Spark. Okay. So this is today's agenda. First of all, I will give you an overview of our system, architecture, and the features. Why the project is started, and what's our purpose of using Spark structured streaming. Then I will introduce how we adopt the Spark structured streaming in our real world case to help resolve customers' problems. The last one, we learn from the real world experience, and we find out that there are some gaps on the structured streaming features, and we want to propose some improvements to this. To the structured streaming. Yeah. So the motivation. So this project is actually Intel is helping one of our customer in China to build a data platform for their manufacturing. Specifically, in this case, it's PCB manufacturing, printed circuit board manufacturing, which is an important segment in the semiconductor industry. We want to build a Spark-centric IoT data platform to fundamentally transform the PCB manufacturing to use this data platform to instruct their product line operation. So this platform is actually an end-to-end data platform, which includes data collection, data processing, and analytics, and visualization, and alerting. And our short-term goal is to enhance a predictive fault repair and material tracking efficiency, which means we can predict if the machine has some potential to be failed, so we can do some maintenance in advance. Or if the material for producing the goods is short, so we can check how much material is left. Then we can resupply the material before it runs out. Okay. The second thing is we want to take advantage of the latest structure streaming. The structure streaming has been official since the current 2.2 version, which is not experimental. It's already official, so we want to try the latest technology. In our case, it includes two things. One is to do a streaming ETL. Another thing is to do a stateless and a stateful processing. I will talk some details later. The third pillar is we are not just try structured streaming. We want to learn how structured streaming works in the real-world problems. If it can very efficiently resolve the real-world problems. If it cannot or it is not working very well, we will see the gaps and we will propose some improvements to the community. Okay. So this is an overview of the PCB surface mounted lines. I'm not the expert on this, but this is very basic production line. So the first you need to print the solder paste to the pad on the board, and then there is several inspection stage. The first one is solder paste inspection. It will inspect if the solder paste is properly placed on the right place. This one is we actually put the components on the pad of the board. This one is called pre-reflow automatic optical inspection. It's another optical inspection before we go to the reflow soldering. The soldering is actually increase the temperature and the solder paste will melt, and then the component and the pad will stick together. Okay. The last one is The last one is post reflow AOI, which is to check if the reflow is correct. So this is the very basic PCB production line. So this is the overall data platform feature. It's not very special for if you do any IoT data platform. You can see a similar architecture and features. I don't want to go through all of this, but it includes a device management, the data collection, the data processing analytics, and some rule engine and actions which triggers alarms or send commands to devices using the rules. And the data visualization, which is web-based user-friendly UI, which can generate interactive data report to fulfill business needs. And the basic requirement for our system is multi-tenancy and scale out and fault tolerance and security. This is not special, but I want to focus today is the data processing and the data analytics. So for the data processing and the data analytics, we want to create some sort of high-level API, which is some domain-specific scripts on top of the Spark, to enable both batch and real-time processing. Spark has an API calls or SQL, but if we talk about the domain-specific, the higher level above the Spark current offers, so we want to do some domain-specific scripts, because those scripts is for for the manufacturing, the factory guy, the staff guy, they may not know how to develop a Spark API using Spark API or Scala. They don't know. They just use some domain-specific scripts. Okay. The second requirement is we can use some machine learning algorithms for advanced analytics. Oh, this is the architecture. So for in the IoT space, so this is the data platform architecture. Actually, in the IoT space, the front end they have different kinds of devices. They can either, if it's a smart device, it can send the data through the MQTT protocol to the Kafka. And if it's not, it will be attached to an IoT gateway, and the gateway will translate the device data and then through the MQTT protocol and to the Kafka. So from the Kafka, we can do both batch processing and the streaming processing. And both batch and the streaming processing, it can utilize the machine learning library. Okay. There is a middle layer, which is application adaptation layer, which is our main effort. We want to build some middleware which encapsulate the feature of Spark and provide a application-friendly layer for the domain-specific users. And on the right side, which is a big data applications. Yes, they can call the Spark APIs directly, but they can use our middleware. Use our middleware to write a very simple script to access the features provided by Spark. Okay, so let's go to the data characteristics of the IoT system, specifically for the manufacturing. So there are different data sources, like the manufacturing execution system, like the data from sensors, cameras, and also some analog data, such like a machine screen output. I will talk a little bit about the screen output, because for some very old device, it only has a screen output through an analog line. It doesn't have a digital output. So what we do is we capture this analog and through analog to digital and translate that to a picture and use OCR to capture the screen the screen information, and we translate this screen information into a structured data type. Then we fit it. We send that into the Kafka. So those data are structured. They have structured, semi-structured, and unstructured data. Some data is they have low frequency, but has a very large amount, such like a picture or a video. Some data it has a high frequency and continuous data. It's not a very large amount per unit, but the total amount is very large. Like the sensor data to detect the quality of the equipment. So there are different kinds of sources and different types of data for this. And how can structured streaming help? So I highlighted some of the key features of the structured streaming. The first is built on the Spark SQL engine, which is high level and very efficient. You don't need to write a very low level APIs if you just do some trivial job, which can be described by SQL. And the second one is it's incrementally and continuously update the final result, so it can handle event time and the late data, and it delivers the end-to-end exactly once fault-tolerant semantics, and it has a very flexible output mode, such like append mode, complete mode, and update mode. The first thing is it supports stateless and stateful operations. I will talk two cases about stateless and stateful operation in the later slides. Let's get to practice. So first thing is streaming ETL. So doing ETL with the structured streaming is very simple. So the standard way to do this is the data is produced from sources and represent the data with a JSON object and transferred with MQTT and saved to the Kafka. Everybody knows the JSON objects are very complex and it may have very deep nested structures. But thanks to the Spark SQL, it has some built-in functions to extract the JSON object and translate them to the very structured type. So you can see the code here. I just use some built-in function like the select expression and get JSON object and cast and alias. Using this built-in function, we can very easy to exact the column and its type, and then cast to appropriate types, and you can name them with appropriate names, and it can be loaded to a table, a very structured table. Okay. So the next one I want to talk about is stateless and stateful operations. Some operations they are stateless, which means the successive operation they are not dependent on the previous operation. Those stateless operation, such like a projection or a filter, so they can run like they can run this stage first and then the next stage, but the next stage is not dependent on the previous stages. The more situation we see in the real world is a stateful operation, which happened very often in the real world case. Spark already has some implicit stateful operation, such like aggregation and time window and join. Those stateful operation, you use the API, you can't. You didn't realize it's actually a stateful operation because Spark do the stateful internally for you. It's implicit. Like you aggregate some result. If you run first batch, you will calculate the aggregate, and you run the next batch. The next batch, the result is aggregated with the first result. Yes, such like a time window, and time window is like you basically divide the whole job to different time window, and the Spark it will track which data is fit in the right time window, and it will calculate the right result. So another thing is Spark is able to do advanced arbitrary stateful operations through a very some low-level API like map groups with state. Okay. So this is some considerations for the structured streaming. You need to consider which output mode you want to use, and you need to deal with late data. I know Spark may use the watermark to handle the late data for you. But if you use the very low level API like map group with state, you maybe need to manually watermark those data. And the third thing is post-processing. Spark has provided some sync for processing the results for you, but you may need to customize this sync to fulfill your actual needs. So I want to talk about two cases in the PCB manufacturing. First one is stateless. It's very simple. You know the solder paste inspection, which is to inspect the solder. If the solder paste is placed on the right place, you have a standard location. That means you place on the right place. Then you use offset XY to measure the offset between the place you actually need to place on the real place, and you calculate the mean and the standard deviation, and you can do some judgment according to the mean and the standard deviation to see if those placement are higher than a threshold. Then you need to report. This situation. So say it's not working because the offset is too large. This is very simple to do with structured streaming API with several lines of code. The second one is more complicated. So which is find out the machine off time from event logs. This is a very complicated one because you need to track sessions from a strings of event and find out the machine off time. So the machine off time is defined as a duration from status off to next on, and the machine will report periodically the status of the machine. So this is the log we captured, but you can see those logs. It's not time-stamped ordered. It's out of order. So if you want to calculate the off time, you need to basically sort the records according to the timestamp, or you will get a long duration. So this is basically we want to use the map group with state API. So first we need to define the event to load the events to this case class, and we need to define the intermediate state, which is the session info, and we want to we want to define session update, which is the final output of our API. So this is basically the standard way of doing map group with state. It's kind of a lot of code, and because it's a very low level API, you need to set the initial state. You need to basically order the timestamp. You need to check the state by yourself, you need to remove the state if the state is timeout, and you need to do a lot of things using this low-level API. Yes, so I have mentioned earlier, we need to order the event time because each successive event depends on the previous event, and this is due to the logical dependence. And we need to handle the later event because if the event is late, it will break the previous calculation result, and it forces us the program to maintain all the events and recalculate if we receive the later events. So we need to do a lot of manual things, such like watermarking for late data, or remove the older events if timeout, and we need to do the incremental calculation by ourselves. Okay, so the last thing is our proposal to improve the structured streaming. The first one is could we enable a flexible window and trigger operation? So in current Spark implementation, there are just timestamp-based window, and the trigger is also time-based. You set an interval, and every several seconds, and it will trigger the operation. So could we implement a more flexible window, like the session, which you can mark the when session start and when session stop, and you can mark this as a window. And the trigger time, you can also do some customized trigger, like you want to trigger in the middle of the window or something. Another thing is CEP, complex event processing. It basically combines several strings and analyze the string and to infer a complicated event. So basically, it includes a string join and session checking and some pattern, like if this event happen, this event A happen and this event B happen several times, and then the C happen, and we mark this as a pattern. Then use this pattern to alert some event to the customer. The third one we propose is the streaming domain specific language. It's a SQL-like language, but it's for strings. Like we can define the schema. We can define the schema for the data source for strings, not just a SQL statement. We can extend the SQL and add some domain-specific language, and the end user can use this very high-level domain-specific language to develop their applications, not just using standard SQL. So we are working on that. We have an engineering team in Shanghai, China, and we are working on those problems. We hope to get back to you later, and we can share our results on those topics. So this is the marketing, and we have another two colleagues talking about Spark SQL. One is adaptive execution engine for the Spark SQL. For the Spark SQL, which is this afternoon, and tomorrow we have a FPGA acceleration architecture, which is using FPGA to accelerate Spark SQL for the workloads. Welcome everyone to join these two sessions from Intel Big Data team. Okay, that's all for me, but the time is out, so maybe.
Cool. Yeah, let's give him a hand.
Thank you. Thank you. You can contact me directly offline, or you can send me email, and my email is on the first page. Okay.
Awesome.
Thank you.
Yeah, that was a great talk. Really great detail about how structured streaming actually works, and I think providing a lot of the boundaries that people need to know about, and I think the recommendations are good. So those are going to be open source pull requests that you'll make for the community, for the DSL, et cetera, or are you guys putting together a design doc, or?
Yes, we will come back later with some real development and the result I can share to the community.
Cool.
Yeah, from Intel side.
Cool. Any questions? I think we have time for one or two, and then we'll jump into the break. Yeah, go ahead.
I was just curious on, you had 1 second time resolution.
Yeah.
Some of our sensors have microsecond, some nanosecond.
Yeah.
With Spark streaming, can you handle that resolution, or would that be a problem?
It will be a problem, but I think with the latest continuous application patch, it can do no micro batch. It can deal with no micro batch, maybe per record. It can reduce the latency for your scenario.
Is your question
because
about
current? Yeah.
Sorry, is your question about latency, sort of being able to respond to an event quickly, or just simply the granularity?
Yeah, the granularity. It wasn't
Yeah.
clear when he presented on. He had nice second intervals, so
Yeah.
you didn't have duplicate timestamps.
Yeah.
I was curious how Spark streaming dealt with duplicate timestamps.
Yeah, so yeah, you can basically do streaming deduplication with structured streaming too. So it can sort of operate on that, and you would say, hey, this timestamp needs to be unique or whatever it may be. But for handling really deep sort of granularity, the timestamp type in Spark SQL doesn't go to, like microseconds or nanoseconds or anything like that. So often what I'll see people do is just simply store it as a long or something like that, and then sort of convert it at that point in time.
Perfect, thank you.
Yeah.
Because I think because it's a micro batch, so you can really deal with the various precision with timestamp.
Yeah, well, he was asking about just sort of handling that within SQL.
Okay.
How do you like convert it to a timestamp and then have the proper
Okay.
granularity, et cetera. But cool, let's give him another round of applause, and then we'll have the break.
Thank you.